For decades, millions of people living on the west coast of North America have been waiting for the big one. We have been told exactly how it will happen. The ground will suddenly roll, infrastructure will buckle, and a single catastrophic rupture along the San Andreas fault will rewrite the map of California. Or, further north, the Cascadia subduction zone will violently snap, sending a towering tsunami toward the coastlines of Oregon and Washington. We have always treated these two massive fault systems as isolated monsters. They live in the same neighborhood, but they operate on their own schedules. But what if the shaking stops, the dust begins to settle, and the nightmare is only just beginning? Geologists have recently uncovered a reality far more terrifying than a single, isolated megaquake. For generations, hazard models, emergency response plans, and city infrastructure have all been built on a fundamental assumption that the Earth will only break in one place at a time. The San Andreas was California's problem. Cascadia was a Pacific Northwest problem. But new scientific research has fundamentally shattered that assumption. It reveals that the San Andreas Fault and the Cascadia Subduction Zone are not independent entities separated by an invisible border. They are, in fact, mechanically linked. This means a massive rupture on one fault is entirely capable of triggering the other. What geologists are now preparing for is a devastating chain reaction. Two continental-scale earthquakes firing off back-to-back, transforming a localized disaster into a synchronized coast-wide cataclysm. This completely rewrites the playbook on seismic threats. To understand how two entirely separate fault systems can communicate across hundreds of miles of solid rock, we have to look deep beneath the turbulent waters of the Pacific Ocean, to a geological flashpoint known as the Mendocino Triple Junction. Located just off the coast of Northern California, the Mendocino Triple Junction is one of the most volatile and complex regions on the planet. This is the exact intersection where three colossal tectonic plates, the Pacific Plate, the North American Plate, and the Gorda Plate, violently crash, grind, and slide against one another. It is a chaotic intersection of immense geological pressure, a subterranean war zone where millions of tons of rock are locked in a perpetual stalemate. More importantly, the Mendocino Triple Junction serves as the critical bridge between our two monsters. It is the exact geographic point where the southern tip of the Cascadia subduction zone meets the northern terminus of the San Andreas Fault. For years, scientists suspected that the immense stress released by a rupture on one of these faults might not just dissipate into the surrounding crust, but could instead travel through this junction and directly influence the other. They hypothesized that a massive release of energy could essentially act like a tripwire, destabilizing the neighboring fault system. However, for a long time, this was just a theory. They lacked the definitive historical proof to show that these dual ruptures actually happened in the real world. Now, thanks to groundbreaking marine geology, they finally have that proof. To find the truth, deep-sea expeditions ventured out into the abyssal plains of the Pacific to extract marine sediment cores. Think of these cores as long, cylindrical time capsules pulled directly from the seabed. By slicing them open and analyzing layer after layer of ancient mud, sand, and organic debris, researchers can read the violent history of the Earth like a heavily guarded book. When a massive earthquake strikes the coastline, the intense shaking destabilizes the underwater slopes of the continental shelf. Millions of tons of sediment collapse into the abyss in massive underwater avalanches known as turbidity currents. When these dark clouds of debris finally settle on the ocean floor, they leave behind a distinct coarse layer of sand and rock within the otherwise fine, undisturbed ocean mud. Each of these coarse layers is a geological fingerprint of a past megaquake. When researchers meticulously examined these sediment cores off the west coast, they didn't just find the fingerprints of isolated earthquakes. They found something that sent shockwaves through the scientific community. They found doublets. A doublet is a pairing of two distinct earthquake debris layers stacked so tightly together that there is almost no normal ocean sediment trapped between them. This means the ocean currents barely had time to settle. The suspended dust hadn't even cleared the water column before a second massive underwater avalanche came crashing down on top of the first. The sediment record is undeniable. It shows that these back-to-back megaquakes have happened not just once, but at least 10 times in the past 3,100 years. This isn't a statistical anomaly, it is a repetitive, established pattern of geological behavior. When you translate that cold, hard geological data into a real-world scenario, the implications are nothing short of chilling. The mechanical link at the Mendocino Triple Junction acts as a highly efficient conduit for seismic stress. Imagine the sequence. The Cascadia subduction zone, a megathrust fault that has been building tension for over 300 years, finally gives way. it violently ruptures, generating a magnitude 9.0 earthquake. The seafloor violently buckles, ripping open across 700 miles of coastline. The sudden violent shift in these massive tectonic plates sends an unimaginable shockwave of stress directly southward, slamming into the Mendocino Triple Junction. That immense pressure doesn't stop. It transfers straight into the northern segment of the San Andreas fault, instantly pushing it past its breaking point. Within hours, or perhaps even minutes, the San Andreas snaps. Imagine the sheer scale of the logistical nightmare. You would have the entire state of California completely overwhelmed. Intense shaking brings down overpasses, shatters glass facades in major cities, and triggers widespread, cascading power failures. Emergency responders, fire departments, and the National Guard are desperately scrambling to mobilize their resources to save millions trapped in the heavily populated zones of the South. And then, before the first major rescue operations can even fully deploy, the ocean abruptly pulls back along the shores of Oregon and Washington. The second rupture has triggered a massive, towering tsunami that is now racing toward the Pacific Northwest. It is a synchronized, dual-front disaster that would immediately push federal and state emergency resources not just past their breaking point, but into total paralysis. We actually have a ghost of this terrifying sequence hidden deep within historical records and native oral traditions. In the winter of the year 1700, a Obayad, colossal earthquake struck the Cascadia subduction zone. The coastal land instantly dropped in elevation, plunging ancient coastal forests into salt water and creating the ghost forests that still stand today in Washington state. The earthquake was so powerful that it displaced enough ocean water to send a tsunami racing entirely across the Pacific Ocean. When the massive wave violently struck the coast of Japan hours later, the local Japanese villagers had felt no earthquake beforehand. They diligently recorded it in their histories as the orphan tsunami, a destructive wave seemingly born from an unknown, invisible origin. Centuries later, geologists finally matched the dates of the ghost forest with the Japanese historical records to trace the tsunami back to the Pacific Northwest. But the new doublet discovery cast a profound and dark shadow over that 1700 event. It is now highly probable that the San Andreas fault felt the immense stress transfer from that historic Cascadia rupture and violently shifted as well. The entire western seaboard of the North American continent may have moved in devastating unison. The threat of a doublet quake, however, extends far beyond the physical destruction of the immediate coastline. The modern world is highly fragile. It is built on delicate networks of global trade, hyper-optimized shipping routes, and just-in-time supply chains. The ports of California, Oregon, and Washington handle a staggering percentage of the United States' total imports and exports. If a double quake knocks these vital maritime facilities offline simultaneously, the economic shockwave would ripple across the entire planet within days. To understand the devastating economic consequences of a major seismic event on a modern industrial hub, we don't even need to look at a worst-case double fault scenario. We just have to look back to Japan in 1995. On January 17th of that year, at 5:46 in the morning, a localized earthquake struck near the city of Kobe. The rupture ripped along the Nojima Fault for just 25 miles. In geological terms, a 25-mile tear is relatively small, but the geographic placement was catastrophic. Kobe was a densely populated, thriving urban center of 1.4 million people, sitting right at the beating heart of one of Japan's largest industrial, manufacturing, and shipping zones. The lateral, sideways shaking of the quake was something the older infrastructure was simply never designed to handle. Traditional Japanese homes, heavily fortified with thick tiled roofs to withstand the brutal winds of seasonal typhoons, were suddenly top-heavy death traps during the intense seismic shaking. Entire neighborhoods collapsed into dust in seconds. The aftermath was a scene of apocalyptic devastation. Over 5,000 people lost their lives, and tens of thousands more were severely injured or trapped beneath the rubble. But the long-term damage to the region's economy and infrastructure was staggering. Almost 400,000. Buildings were irreparably damaged. Subterranean gas lines ruptured across the city, sparking over 300 massive fires that burned uncontrolled through the equivalent of 70 city blocks. Elevated highways snapped and rolled over, and 85% of the city's schools and hospitals were left completely unusable. The economic toll reached a staggering $200 billion. The port of Kobe, a vital artery for global shipping, was heavily damaged and shut down, sending shipping timelines and supply chains into chaos worldwide. Manufacturing lines froze. The financial shock was felt across global markets. Japan is an incredibly resilient nation. they immediately poured $58 billion into emergency recovery. They aggressively rewrote their building codes, completely overhauled their disaster management systems, and pioneered the incredible early warning technology that saves countless lives today. But even with that massive effort, it took years to rebuild the port and nearly a decade for the local economy to fully recover to its pre-quake levels. Now, take that level of destruction and scale it up exponentially. Kobe was just a 25-mile rupture on a single fault line. What happens when 700 miles of the Cascadia fault tears open, followed minutes later by hundreds of miles of the San Andreas? You are no longer looking at a localized disaster that a nation can easily absorb. You are looking at a complete, systemic freeze of the global supply chain. Grocery prices would spike globally within the week. Gas availability would plummet. The manufacturing of electronics, vehicles, and critical medical supplies would hit a brick wall as the massive ports of Los Angeles, Long Beach, and Seattle go dark simultaneously. The world is too deeply interconnected today for a disaster of this unprecedented magnitude to remain a local problem. Scientists are no longer asking if this linked doublet earthquake sequence will happen. They know the geological heartbeat of these fault lines. They have seen the undeniable evidence written in the ancient mud at the bottom of the ocean. The only question left is when the next sequence will begin. We can no longer afford to prepare for just one earthquake. Governments, city planners, and engineers must rewrite their emergency playbooks to account for a chain reaction. Because when the ground starts shaking on the West Coast, the first quake might just be the warning shot. If you found this deep dive into the hidden, terrifying mechanics of our planet eye-opening, make sure to hit that subscribe button and turn on notifications so you never miss an upload. Drop a comment below and let me know. Do you think our modern cities and global supply chains are truly prepared for a doublet earthquake? Stay curious, and I'll see you in the next video.